Willis Tower, an iconic structure in Chicago's Loop that established a global standard in high-rise design and construction. Join us to experience an icon from the street to the sky. In 1895, Richard Sears and Alva C. Roebuck started Sears Roebuck, a leading mail-order company of the 20th century. To accommodate the size of the business, Sears purchased 40 acres of land on Chicago's west side for the company's headquarters and main operations. To consolidate the company's operations scattered all over Chicago, the company announced in 1970 that it would construct a new headquarters on the western edge of Chicago Loop. Immediate space demands and predictions for future growth necessitated an office building of over 3 million square feet. Instead of building horizontally, architects Skidmore, Owings and Merrill proposed a tower with small footplates to yield sufficient square footage. The final tower stood 108 stories above ground, surpassing the height of New York City's World Trade Center to become the world's tallest building. Unfortunately, Sears' fortunes began to decline after moving into their new headquarters. By 1995, Sears had completely vacated the building. Then Willis Group Holdings moved into the building in 2009. Bruce John Graham was a Colombian architect. Some of Bruce Graham's notable works are the John Hancock Center, Hotel Arts, The Guardian, and Broadgate. He is known for integration of modernist design and sophisticated engineering. His works are a bold and muscular interpretation of Messian glasswork. The structural engineer Fazlur Khan designed the tower using a new tube structural system. He used a bundle tube system grouping 9 square tubes together, connected as a single unit. Took out his packet of cigarettes at lunch, bunched together 9 individual cigarettes in one hand, and from that simple action figured out part of the design of the world-famous skyscraper. The evolution. 1970. Construction begins on Sears Tower. 1973. Construction of the structure is completed, making it the tallest building in the world. 1984. The tower's iconic broadcast antenna are added. 1985. The Wacker Drive atrium is added to the base of the tower, featuring a distinctive art class construction. 2000. The sky deck undergoes its first renovations. 2009. Sears Tower is renamed Willis Tower. 2015, Blackstone purchases Willis Tower. 2017, the 5-year-long renovation plan begins. 2022, completion of renovations. The structure was designed as 9 squares arranged in a 3x3 matrix, forming a square base with 69-meter-long sides. Each tube is a module measuring 75 by 75 feet, which then set back at different stories. The height to width ratio of the structure is 6.45:1. Let's now look into the foundation details. A 3-foot thick wall was dug around the perimeter of building site. Bentonite clay slurry was poured into the excavation panels to prevent ground collapse and infiltration. The excavation panels reached approximately 5 stories into the ground. The entire site was excavated to 50 feet. 114 reinforced concrete caissons of varying diameter were dug another 50 feet into the earth. A 5-foot concrete mat was poured at the bottom of the excavation site, which tied all caissons together and became the bottom level of the Sears Tower. Geophysical loads. Typically, these loads transfer through the horizontal support systems to vertical load carrying element, then to the foundation systems, and finally to the underlying earth. Loads distributed to slabs are typically supported by girder framing, then by stanchion. The load is transferred in the same manner in this structure. When any load is delivered to the metal deck floor, it will convey the load to MSI section girder. Then from girder, the load will be transmitted to stanchion. Stanchion will move this load to caisson pile foundation. The foundation will bear the entire load that is directed from the structure. Lateral load. Wind and earthquake load plays major impact on building deflection. When the structure is subjected to lateral forces, belt trusses that connect the outer perimeter column of the structure offer a wider perimeter to resist lateral deflection of building and enhance stiffness of the structure. The frames resist the shear, while the flange frames carry most of the overturning moments. The building contains 104 elevators, including 14 double-deckers. These double-decker elevators carry passengers to the sky lobbies on the 33rd and 34th floors and the 66th and 67th floors, where they can transfer to local elevators. Bracing. All the tubes of the structure are bundled together by belt truss. They appear as black horizontal bands on the facade around the 29 to 32nd floor, 64th to 65th floor, 88th to 89th floor, and 104th to 108th floors. The belt trusses are obscured by louvers to ventilate the space. It acts as a main horizontal connector located at the mechanical floors of the building. It connects the outer perimeter column of a building and offers wider perimeter to resist the lateral deflection of a building. It is also used to control deflection due to lateral loads and enhance stiffness of the structure. The tower structure is solved with 9 square modules, each rigid within itself without internal supports. The floors are suspended from the tubes based on the theory that a building built on a series of tubes would be lighter and stronger than a building built to a traditional steel skeleton. At the base of the building, 9 modules form a square of 22.86 into 22.86 meter, grouped as a closed square, and arrive intact through the first 50 floors, finishing at different heights and creating a form with multiple levels. From this level, the number of modules or tubes is decreasing until it became only 2 steel tubes from the 90th floor to the top. Building services such as electrical, plumbing, and mechanical systems are installed in the building, making it comfortable, functional, and efficient. The structure was equipped with a firefighting system, even though regulations did not require a fire sprinkler system with around 40,000 sprinkler heads. Furthermore, the tower contained fire suppression and communication systems for emergency use, which were powered by diesel generators. If there was a fire in one section of the building smoked. The tower was heated electrically, unlike older structures that used gas heating. It included 1,45,000 light fixtures and a cooling system capable of 17,000 tons of refrigeration. The unique phenomenon in super tall buildings is stack effect. Essentially, hot air rises and is replaced by cooler air from the outside of the building. The profound difference in temperature causes air on the ground floor to be sucked into the building, creating a massive draft. Steel connections. Around 78,000 of structural steel are fabricated and erected for the Sears Tower. The structural steel frame was pre-assembled in sections and then bolted into place on site. The assemblage of different members such as girder, stanchion, truss, etc. is done through bolting and welding to make them act. Chicago experiences sunrise directly in the east twice a year on the spring and fall equinoxes. On those days, the sun also sets directly in the west. Direct positive pressure is exerted on the surface facing the windward side, which produces a great force on the structure. Negative pressure occurs on the leeward side of the structure. Since the winds flow like a liquid, there is a drag effect on the surfaces parallel to the direction of wind. The wind hits the structure at an angle from southeast direction, so it accelerates the wind on the sides and large pockets of turbulence is created on the opposite side. Skin, lightweight, black aluminum and bronze tinted glass reduces reflections and serves as insulation between the inner and outer structure in order to maintain a relatively constant temperature, which minimizes the expansion and contraction of the frame. Skin, lightweight, black aluminum and bronze tinted glass reduces reflections and serves as insulation between the inner and outer structure in order to maintain a relatively constant temperature, which minimizes the expansion and contraction of the frame.